Alright, here's the review for the test. The very beginning has an entire vocabulary section. Make sure you get familiar with these terms. But I'm going to start on part 2 here. So part 2 asks us to dilate the image by a scale factor of 2 from the center of dilation P. So in order to start my dilation, what I need to do is all 4 points here need to be connected to point P. So using your straight edge, connect all 4 points to point P. Great. Now what they asked us to do is to dilate the image by a scale factor of 2. Well, every pre-image is considered a dilation of 1. So essentially what I need is I need these lines to be doubled. There's a lot of tools you can use. You may use a compass. You could use paper. You could also measure with a ruler. In this case, with paper, you would just measure your paper along here and here and move it along. So regardless of which tool you use, your image would look like this. So I will just copy these. So of course you don't have a copy-paste button, but you have tools to do that. You can use a compass, you can use a ruler to measure, or paper. The paper is the most accessible of the tools. So I'll mark all these points, and what we're going to do is we're going to create this T. So I will connect here and here. And then connect here and here. Great, so this image has been perfectly dilated. So this section, this line here, is now happening one more time. If this was a dilation of 3, I'd have to go 1, 2, and then create a third copy of that line here. But regardless of which tool you use, it should look like this. Alright, the next one here asks, given the pre-image and image below, determine the scale factor. So thankfully you don't actually need to connect anything. All you really need to know is how much has the image been changed by. So first thing you need to do is determine the pre-image. This is your pre-image. So it looks like the larger figure is the original, and the image is the smaller one. What you want to know here is how much bigger, or in this case, how much smaller is the image compared to the pre-image. So what you would do is pick a side of the image, pick a side of the smaller one. And what you're going to do is see how many of these smaller ones will fit here. So I have 1, 2, 3, and 4. So it's about 4. So in this case, 4 of the images will fit in the pre-image. Well, the scale factor is not 4 in this case, because the pre-image got smaller when it became to the image. So rather than 4, your scale factor is 1 over 4, 1/4. So again, any tools you need. You may use paper, you could use a compass, you could use a ruler, even your fingers would suffice. You just need to make sure you know how the image and pre-image have changed. And for this one, now instead of dilating it by a larger scale factor, you're dilating it by a smaller scale factor. So this needs to get smaller. So as usual, I will connect M to the center of dilation P. I will also connect T to center of dilation P. And now I need to find the halfway mark. So I need to find half of PM. I need to find halfway there. So what you could use, again, you could use a compass, create a perpendicular bisector. You could use paper, mark your paper, fold it in half and find the center. You may also measure with a ruler. In this case, on this board, I do not have a ruler, so I'm going to use the compass. So the compass method takes a lot longer than the others, so I would really suggest using paper. So perpendicular bisector. It wasn't properly done. As you can see, I didn't make my compass wide enough, but I can tell that the center point is going to be right there. Let's erase the compass markings here. And then I'll do it again here. Let's make it wider this time. Maybe that'll work. Nope, that's not going to work. Make it even wider. There you go. That should be good. Yeah, if you know how to do this, you can totally skip this part. There. Now, I would normally draw a line here, but I can tell that the center is going to be right there. And again, you can find the center using any tool. It does not have to be a compass. Great, so I found halfway here, and now I simply will just connect the 2 points I drew. There. So, great. This has been it's been dilated by a scale factor of half. That means this new line I created, I suppose I should label this M prime, and T prime is half the length of MT. So now here comes dilations, except in a coordinate plane. So we've got a triangle, dilation, dilate ABC by a scale factor of 1/4, with a center of dilation at 0, 0. Now the best way to dilate, in my opinion, is to think about how do I get from the center of dilation to each of the points. So I like writing out the directions. So to get to point A, what do I need to go? From the center, I go 4 spaces up. To get to B, where do I need to go? 4 right and 4 down. So right 4 and down 4. And how do I get to C? I need to go left 4 and down 4. Now, what I want to do is I want to dilate it by a scale factor of 1/4. That means I want to divide all of these by 4. So what would happen? Well, A prime would no longer be up 4, it would be up 1. B prime would no longer be right or down 4, they would in fact both be 1. Because 4 divided by 4 is 1. And same with C, so be left 1, down 1. You do not have to write these directions, you simply need to find the appropriate dilation. So go up 1, that is my A prime. B is right 1, down 1. B prime, C left 1, down 1, C prime. And there, the triangle has been dilated. And it is 1/4, you can tell because the bottom side of the image has 2, but we got 1, 2, 3, 4, 5, 6, 7, 8. We got 8. And 8 is definitely 4 times bigger than 2. So here's a dilation at 0, 0, not bad. Next, they've asked us to dilate 1/4 again, and it's the same image except the center of dilation is going to be at point A. Well, it's unique. So if this is my center, then how would I get to A? Well, I don't really need to do anything. A, I would just say the directions are 0. Near 0 meaning don't move. How would I get from the center to B? I need to go right 4 and down 1, 2, 3, 4, 5, 6, 7, 8. B, I go right 4 and down 8. For C, I need to go left 4 down 8. And to apply the scale factor, I take everything and I just divide it by 4. Well, 0 divided by 4 is still 0. Oh, so don't move. B, right 4 means right 1. Down 8 is now down 2. All of them have been divided by 4. C prime, left 1, and down 2. All right, so let's do this. From this point, don't move. All right, that's A prime. B prime is down 1. No, right 1, down 2. C prime is left 1, down 2. And it looks like a triangle. There you go. So the point of dilation was on the shape, so therefore the shape is still inside. Okay, not bad. What about this one? Dilate again 1/4, except the center is at 2, -2. So 2, -2 is the center. Let's mark it. And as usual, write the directions to get to each of them. To get to A, I go left 2 and up 1, 2, 3, 4, 5, 6. A is left 2 and up 6. B is right 2 and down 2. If I was here, how do I get to C? 1, 2, 3, 4, 5, 6, 2. So left 6 and down 2. Take all of these directions, divide all of these by 4. Unfortunately, we're going to get some decimals here. 2 divided by 4 is left of 0.5, or 0.5, but not 0.5, just half. Right? Instead of up 6, it would be up 1.5. Prime, forgot that. B prime. And we've already done this, right? 1/4 of 2 is 0.5. So now that we've done the, we've applied the scale factor to some of the numbers, we kind of know all the answers now. 1.5 and down 0.5. So starting from the center, let's follow our instructions. Left 0.5, up 1.5. And that is my new A prime. B, I go left 0.5. Nope, not left. Looks like I made a mistake. That's right 0.5. Yeah, there we go. Right 0.5. So right 0.5 and down 0.5. That's your B prime. C is left 1.5, 1.5 and down a half. C prime. I'm going to connect this. That is not pretty. 1, 2, and 3. So, there we go. There's our dilation. If you notice, all 3 triangles that we have done, they're exactly the same size. They're just in different positions. So the scale factor will keep the size, having the same scale factor will keep the size consistent, but the position depends on the point of dilation, or the center of dilation. So that's an interesting fact. Okay, so now here, they have given us a dilation, and what we need to do is we need to figure out what the scale factor is and what the center of dilation is. Well, first we need to identify the image and the pre-image. The pre-image in this case is the smaller one. The image is the larger one. So if it's from smaller to larger, you know the scale factor should be bigger than 1 because this is an enlargement. It's getting bigger. So scale factor. Well, pick any side. Let's pick AB. That's 1. How big is it for the new one? 1, 2, 3, 4. So the scale factor is 4. The sides have become 4 times larger. Now the center of dilation is found where all the image and pre-image points meet. For example, if I connect B and B prime, I just draw a line there. If I connect C and C prime, and I connect A prime and A, where are these lines all pointing to? All of these lines point there. That is your center of dilation. So in this case it is -2, -2. So connect, again, A prime and A, B prime and B, and C prime and C, and keep going, and you should find that they all will connect to this point right there. All right, next here. All right, given the pre-image and image to the left, identify the following. Same thing, scale factor and center. So, pay attention. What's the original? The original this time is larger. The new one is smaller. So here, well, if I see CA, you can kind of tell just by looking that the original is twice as big as the new one. That means the new one is half the size. So the scale factor is half. You can also confirm by measuring with paper. You can also see that this is 1, 2, 3, 4, 1 to get from C to A. But to get C prime to A, the C to A is 8, 2. So the directions are even shortened. And where's the center? So you connect C and C prime, B and B prime, A and A prime. What are all these lines pointing to? They're all pointing towards this point there. That is your center. So your center of dilation is -2, 1. Okay, and I don't need these anymore. All right, 9. So here they've asked me to dilate it, but it's a negative scale factor. So this is a little difficult. The image is going to get 2 times larger, but there's going to be some kind of flipping going on. So first we're going to start just by writing the pre-image coordinates. J, K, and L. So what is the original J? J is 2, 4. K is 1, 1. And L is 4, 0. Now usually with dilations, we wrote the directions and followed the directions, or multiplied the directions. Because this is centered at 0, 0, rather than writing the directions, you can actually just write the points and multiply -2 to all of the points. So in this case, J prime, K prime, and L prime. 2 times -2, that's going to be -4. Multiply this by -2, you get -8. So we're multiplying all these numbers by -2. They should all end up like this. And 0 times -4 is just 0. Great, so let's just write these points. -4, -8, 1, 2, 3, 4, 5, 6, 7, 8. This is your J prime. Next is -2, -2. Easy, right here. That is your K prime. And L is -8, 0. That is your L prime. So, great. Now we can connect all these. I don't trust myself being able to go that far, so I'm actually going to use the line tool. There. So, great. The image is twice as big, and it's actually now facing in the other direction. So, this is how you, this is, in my opinion, the quickest way to perform a negative dilation. Simply just multiply by the scale factor. This multiplication trick with the points can only happen at 0, 0. If it were at a different center of dilation, you would need to write the directions and multiply the directions. In this case, if you make it negative, you'd need to switch the left and right. All right, here again, it's another dilation. Thankfully, it's at 0, 0. You shouldn't see any dilations, any negative dilations that are not at 0, 0. That is a bit too difficult for the scale of this class. A, B, C, and D. So let's write the points again. A is negative 3 comma 4, B is 3 comma 2, C 5 negative 8, and D negative 7 negative 6. Please make sure your points are correct. If your points are incorrect, your image is certain to be incorrect. Now in this case it wants me to multiply by negative half. Remember, negative half is also the same as multiplying by negative 0.5. If fractions are scary to you, you can choose to use the decimal instead. However, they shouldn't be that bad. So half of 3 is 1.5, but I'm multiplying by negative. That means this needs to change to positive. Half of 4 is 2, but since it's a negative 2, right? B prime is going to be, again, so this is negative 1.5, and 2 is going to change to negative 1, just multiplying by negative half, or negative 0.5. C, half of 5 is 2, so negative 2.5. Half of negative 8 is negative 4, but I need to make it a positive 4. D prime, negative 7 becomes positive 3.5, half, and change the sign. 6, half of 6 is 3, and it should be positive 3. So let's just draw this image. 1.5 means it's in the middle, and down negative 2. So that is your A prime. B is negative 1.5, 1.5 negative 1. That's your B prime. C is negative 2.5 and up 4, 1, 2, 3, 4. That is your C prime. And for D, that's 3.5, 1, 2, 3. So right on where the letter B is. Again, connect these. And as we can see, it's the same shape, it's just half the size, at least in terms of the sides. And it's facing the other way. It's been flipped. So easiest way, use your points. All right, so this part here is now dealing with triangle similarity. I would like to know, is HIJ, which is the inner triangle, is that congruent to GIK, the larger triangle? Well, I do need to fill in some information here. I do know the sides of the larger triangle, that's 15 and 9. I only have one side of the small triangle, 6. I would like this side. Well, cool. If the whole thing's 15, and that's 5, this one obviously must be 10, because 10 and 5 add to 15. So, what I would like to do is check that these sides are proportional. If they give you sides, check they're proportional. 15 over 10. That would be 1.5. And if I do 9 over 6, that's also 1.5. Because this side matches with this side matches with that one. So great, they both have the same scale factor, but that's only for two sides, right? I either need a third side or an angle. Well, the third side has no information at all. However, I do know that angle is congruent in this triangle. That angle exists in the small one, and it exists in the large one. They're the same angle. We call that the reflexive property. So, are these triangles not congruent? Are these triangles similar? They are absolutely similar. They are similar by the SAF. That's side angle side. By side angle side, since each triangle shares two proportional sides, and a congruent angle between the sides, and a congruent angle between the sides. So this is an example of the SAS rule, or theorem, postulate, whichever word. So you got to check the sides are proportional and look for any congruent angles. Next one here. Okay. Well, I have a bunch of sides. I have 3 sides of this triangle. I have, what about the larger one? I got this 27 for the big one. This 36 for the bottom side. I'm missing this side though. Well, I do know 8 and 16, right? Well, 8 and 16, they add to 24. So I know that this large missing side of this triangle is 24. I've got 3 sides. This is definitely a side, side, side. But I need to check if it actually works. It may not work. So let's pick that side. 24 divided by 16. I would not use the 8 because that's not part of a triangle. That's part of this trapezoid here. So 24 divided by 16. See, can't do math in my head. That's 1.5. What a coincidence. 27 over 18 is also 1.5. 36 over 24. And it's finally, again, 1.5. Great. All 3 sides got the same scale factor, 1.5. Therefore, they are similar by SSS. So, are they similar? Yes, they are. They are similar by SSS, side, side, side. And what does that mean? That means all 3, or because all 3 sides on both triangles are proportional. Right. There's an extra question here. So then what can we say about TV and SW? TV and SW. So this was an interesting fact, but if you have a triangle inside a larger triangle, and specifically, and also 2 of the sides are being shared, essentially you're constructing a triangle by cutting a line through that triangle. These 2 lines will be parallel. So what this means is TV and SW are parallel. So since the triangles are similar, TV is parallel to SW. If the triangles were not similar, then we can't say they're parallel. We aren't sure. We don't know for sure. Right. Moving on this one. How about this one? Are these similar? Well, we got to check the sides. This could be another side, side, side problem. It's nicely set up for us. So there's a lot of sides. It is a bit confusing. So the way we work is you always match the longest side with the longest side. So I just put circles there. All right. What's the smallest side? That's 8. And what's the smallest side here? 5. I'm putting different shapes to match the different ones. And finally, left over is 9 and 6. So let's try this. 12.8 divided by 8, because they're both the largest sides on their respective triangles. That's something. 8 divided by 5. And make sure you pick the same division. If you did the larger triangle by the smaller triangle, you need to make sure you do that with each side. So if you did 12.8 over 8 and 8 over 5, you don't suddenly want to switch to 6 over 9. It's got to stay 9 over 6. 9 over 6. So if it's bigger over smaller, it's got to be bigger over smaller. You can't switch decisions here. 12.8 over 8, that's 1.6. 8 over 5 is 1.5. No, 8 over 5 is not 1.5. 8 over 5 is 1.6 as well. 9 over 6 is 1.5. That's strange. So I got a 1.6, a 1.6, and a 1.5. So this is a situation where you think they're similar because it could be side, 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 but turns out we got one bad thing going on here. So in this case, they are not similar because all three sides do not have the same scale factor. These pairs of sides were great. This one ruined everything. So they're not similar. They're not similar. All three sides all three corresponding sides do not have the same scale factor. So if one side is even off, it breaks similarity. All right, last one here is a proof. So, great. They told us they were parallel. So before we start a proof, besides writing the given, it never hurts to write a given. So I guess we can write that, just get it out of the way. MQ is parallel to NP. That was given. So we need to prove these triangles are similar. So remember, there are three triangle similarity theorems or postulates. You got SSS, you have SAS, side angle side, or angle angle. Remember angle angle? If I got two angles, I do know the third one. So angle angle is the same as angle angle angle. Anyway, so because these lines are parallel, that allows me to use two types of special angles. I can now use alternate interior angles and alternate exterior angles, I guess, but exterior is not very much used. I can also use corresponding. And if you look here, these two are corresponding. I have two parallel lines and a line that hits the two parallel lines. And the angles created by that line must be congruent. So I know that, I can just call this M, I know that angle M is congruent to angle, and I can't just call it N, 3 letters, because N could be this or that. N is ONP, angle ONP, and this is by corresponding angles, because they are corresponding angles. Remember, you cannot use corresponding angles unless you state that the lines are parallel first. Next one here. What else is congruent? Well, this is everyone's favorite. O, right? O exists in the small triangle. It also exists in the large triangle. Angle O is congruent to itself. This is called the reflexive property. Angle O is congruent to angle O, reflexive property. Everyone's favorite. So I have two angles now. I got these pairs of angles and these pairs of angles. I have an angle-angle relationship. Therefore, I can use this one. Great. Angle-angle. So finally, I can state, I can finish my proof. Triangle QMO is similar to triangle PNO, and this is by the angle, we can just call this postulate. All right, awesome. We do got a little challenge question here. Prove that they're similar using a different set of reasons. So, right, this isn't the only proof you can do. There's actually a third angle that we did not touch. So, OPN, and Q are also congruent because they are corresponding angles as well. So, rather than writing corresponding reflexive and angle-angle, you could have used these two angles in your proof instead. So angle-angle using this blue and green one versus the blue and red one before. So there are multiple ways to complete these proofs, and all of them should be correct. All right, that's it.